Hello everybody, and welcome to a new episode of Back to Basics. This week, we're going to talk about transistors. Now, pardon the sound of the air conditioner in the background, it's really hot in here today, so I've got it running. Anyway, last week we talked about diodes and how the PN junction makes it so that current can't flow if you don't have the diode biased in the right direction. Well, this week we're going to talk about transistors. Now, transistors come in two different types. We have Pnp transistors and we have Npn transistors. And they are basically the same device except for their construction. So the symbol for a Pnp transistor looks a little bit like this. Actually, those are typically straight. And an Npn transistor is going to look like this. And the letters Pnp and Npn stand for the type of semiconductor material that they have been constructed with. So with a Pnp transistor, you have a piece of semiconductor material. Apparently I've got a cat hair stuck to the tip of my dry erase. And it has three pieces of semiconductor material in it. Two pieces of P material, and one piece of N material. And it's the same thing for an NPN transistor. We've got, are these showing on camera? Let's scoot that up a little bit. Only with an NPN transistor, we have, again, a small sandwich here. And it has N material on the outsides. And P material on the inside. And these basically are two diodes sandwiched back to back. Now you can't actually take two diodes and twist the ends together and make a transistor. The base, which is this center piece here, I forgot to write, oops, P, there we go. The base material is only several microns thick, very, very, very tiny piece of material on the base. But because of the existence of the N or P material in the center of these materials, it creates a region where current can't flow in either direction. It doesn't matter which way you bias it, current isn't going to flow. So in order to get current to flow through a transistor, you're going to need to induce a small amount of current in the base of the transistor, and then current will start flowing from the collector to the emitter. Let me actually write those down. So the base is this part, and then the collector on the Pnp transistor and emitter. And the terms collector and emitter, and then the emitter is the arrow on this one, and collector here. The terms base, collector, and emitter are terms used to describe what they're doing. So the base, that term came from the fact that the P or N material in the center of the semiconductor, it actually used to be a several microns thick, and they might actually still do this. I didn't very thoroughly research the actual construction of transistors. I probably should have before I started. But the base is a very small, tiny, thin wafer of the N or P material, and then on the ends of it, you get larger sections of P or N material based on the transistor. And the emitters, oh, I'd better confirm this. Give me a second, I'll be right back. Alright, I'm back. I just needed to check something on the construction of transistors really quickly. So this is the more modern way of building a transistor. It's the epitaxial. So whenever you see most modern transistors, it'll say Pnp epitaxial transistor or Npn epitaxial. And epitaxial is a fancy name for ordered layers. And so what happens is you have a crystal of, in this case, N material, and then a crystal of P material is grown into it, and then another crystal of N material is grown into that. Now, the emitter in most transistors is very, very heavily doped, which means that the current flow likes to move towards the emitter more than the collector. And of course, for a Pnp transistor, these layers will be the same, only the P and N materials will be switched. So that's pretty much the basics of construction. I'm going to do a really quick practical demonstration here to demonstrate the difference between a Pnp and Npn transistor in circuit. So I'm just going to quickly erase all of these. There we go. And I'm going to sketch out a quick circuit here. So let's do Pnp over here again. And Npn here. All right. So for an Npn circuit, we're going to have a voltage source, and it'll come up here. We'll bring it over here, and actually I'm gonna move this voltage source down a little bit. There we go. And we'll draw in our little Npn transistor here. Boy, I'm just not doing very well with my proportions. Okay, so the Npn oops. Doing this wrong again. So let's start over here. So the load on an Npn transistor is on the collector side. So I've actually got some stuff built over here. Resistor, and then we'll throw in a light emitting diode. And then from there, we'll go to the the transistor, and then the ground. And that's the NPN. I remember the style of the transistor by saying not pointing in, so the arrow is pointing out. It's not pointing in. And then we're going to come down from here. We're going to have a little switch, another resistor. This is a very basic, just demonstrative use of a transistor here. So we're going to have 4.5 volts here for the demonstration, and this is a 100 ohm, this is 100 ohm, and for the switch I'm just using a wire link. So in order to get current to start flowing through this transistor, we have to induce a current in the base. Now, we'll cover the concept of beta later, but I'll just touch on it now. There is something called beta with a transistor, and with the ones I'm using, I think the beta is equal to about 60. And that basically means that any current that is being induced at the base is multiplied by 60 from collector and emitter. So with conventional current flow, we're going to induce a current flowing through the base and into the emitter and then down to ground. And whatever current is flowing through there is then multiplied from collector to emitter. So let's say we induced 10 milliamps here, we'd induce 600 milliamps from the collector to the emitter. Now it's the same kind of idea with a Pnp transistor, only I'm going to just quickly re-verify with my... Yeah. So with a Pnp transistor, we're going to come over here, we're going to come down a little bit, and then the load is actually on this side. And then the arrow is pointing in. And then we come down here. And in order to get a Pnp transistor to open, you actually have to pull the base to ground. So you're inducing a current from emitter to base by pulling it to ground, and then that current is multiplied then through emitter to collector, through the resistor, and then through the LED, with the same concept of multiplying the current by the beta. So this doesn't really show it very well, so I'm going to switch my setup around a little bit here, and we're going to do a quick demonstration. Alright, and we're back. I have some breadboards here and some components, and I decided we'd actually go ahead and build them on camera as well. So let's start with the Pnp circuit. Now, with transistors, you'll find that there is a flat side on them. I'm not too sure how well it's going to show, but let's bring it up. See how it's sort of semicircular there, and there's some writing on the front? Well, when you're looking at the writing, the pinout is emitter base collector. So we're going to go ahead and throw this guy kind of just right in the middle here. Then we're going to take one of our resistors and put it to the base of that transistor. And then from, in this case, because this is the PNP, the collector, which is this side, we're going to take our resistor and put it from the collector and up, and then we'll take our LED, and I'm just making sure I'm doing this right, yes, and then because that's going to be the negative side, we'll put this there. Alright, now if I set everything up correctly, we're going to take our positive rail and we're going to put it at the emitter. And the reason why the emitter is going to the positive rail is because with electron current flow, the electrons are being emitted from the emitter. But for conventional current flow, the positive goes through there. So at some point I will do a more concise explanation of conventional versus electron current flow. But anyway, so we're going to take our negative and put it at the bottom of the LED here. And then we'll take the base and we'll put a little jumper wire here. Now, if I did everything correct, we're going to want to pull the base negative for the PNP transistor. So I'm just going to take it over here, connect it to this negative rail, and the LED pops on. And the LED pops on because we've now induced a current from emitter to from emitter to base, and that current is being amplified from the emitter to the collector, or collector to emitter rather. So let's do that same thing, only with an NPN transistor. So same pinout, we'll take it and put it in the middle here, assuming we can actually get it to go into the breadboard. These aren't the most high quality breadboards in the world. There we go. And then we'll take our resistor and put it to the base just like the last time. And then in this case, what we're going to want to do is put the resistor at the collector, which is let's see, the collector on this one is here. And then the diode, which we have to make sure the polarity is correct there. Actually, for the purposes of this schematic, I actually have it set up with the diode here. And then the resistor. Alright, now we're going to take the positive rail this time and put it up here at the top there, and the negative rail and put it there, and then we're going to take the base, and we actually want to pull the base positive this time. So we'll put the base on the positive rail, and again the LED pops on because we're inducing a current from base to emitter, and then from collector to emitter the transistor is now conducting. Anyway, just a quick exploration into transistors there. If I left anything out or made anything unclear, feel free to start a discussion in the comments below. Ask lots of questions. If you haven't already, consider clicking here to subscribe. Right over here will be a video that YouTube thinks you'll find interesting based on your watching habits. Right over here will be the Back to Basics playlist, and right here will be a link to Patreon, which you can use to support further videos like this one. Thanks so much for watching, and we'll see you next time. Bye-bye.